Welcome back to my YouTube channel Grandpa Mathematics. Today let us learn how to evaluate the definite integral by substitution method. In this integral, if we differentiate x square plus 1, we are getting 2x dx. So that means x dx becomes a part of dy. So let us take x square plus 1 as y gives what? 2x dx is dy. We have to change the limit of this integral also. When x is 0, what is the value of y? Y is equal to 1. When x is equal to 1, y is equal to 1 square, 1 plus 1, 2. Therefore, the integral 1 becomes equal to integral x varies from 0 to 1, y varies from 1 to 2. So, 1 to 2 x dx. X dx is dy by 2 and x square plus 1 is y. So we'll take 2 outside the integral. 1 by 2 times integral 1 to 2 dy by y. What is integral dy by y? That is nothing but log y. So you can write this as half times log y, limit 1 to 2. So you can write this as half times, put the bracket, because 2 term comes. First is substitute the upper limit for y. So log 2 minus log, for y substitute the lower limit 1. So this is equal to half times log 2. This is the answer, because log 1 is equal to 0. The value of log 1 is 0. So half log 2 is the answer. So do the same problem without substitution directly. Know that if we differentiate x square plus 1, we'll get 2x. So write this as 1 by 2 times integral 0 to 1 2x by x square plus 1 dx, half time integral 2x by x square plus 1 dx is log of x square plus 1, limit x varies from 0 to 1, half times now log of, we put x is 1, 1 square plus 1, so 2 minus log, x is 0 means log 1. So this will be half times log 2 minus 0 is equal to half log 2. So this is the answer. So in this integral, sin phi is there inside the square root. Therefore we can take sin phi is equal to y. On integrating sin phi, what we are getting? Cos phi d is equal to dy. So in this 1 cos phi, d phi becomes a dy. When phi varies from 0 to pi by 2, so when phi is equal to 0, What the value of y we are getting? Y is sine 0, that is nothing but 0, when y is equal to pi by 2, y is equal to sine 90 degrees. Sine 90 is 1, so is 1. That means when pi varies from 0 to pi by 2, y varies from 0 to 1. 0 to pi by 2, square root of sine phi, then cos square pi whole square, cos pi d phi. Again this is equal to 0 to pi by 2 square root of sine phi, 1 minus sine square pi whole square, cos pi d phi. Now we'll change the limit. This is equal to integral d phi, varies from 0 to pi by 2. Now y is 0, y is 1. Y varies from 0 to 1. Square root of y, this is 1 minus y square whole square. This is nothing but dy. Now we can write this as integral 0 to 1 y power half. We'll expand this 1 minus 2y square plus y power 4 dy. 0 to 1. We'll simplify this. Y power half into 1 is y power half, minus 2 times this y power 2, y power half, y power 5 by 2 plus y power half into y power 4, that is y power 9 by 2 dy. So this is in the form of integral x power n dx. If we integrate x power n with respect to x, what we will get? X power n plus 1 by n plus 1. So this will be y power half plus 1. So 3 by 2 by 3 by 2 minus 2 times y power 5 by 2 plus 1. So y power 7 by 2 by 7 by 2 plus y power 9 by 2 plus 1, 11 by 2 by 11 by 2. Limit 0 to 1. This is 2 by 3 times y power 3 by 2 minus 2 into 2, 4 by 7 times y power 7 by 2 plus 2 by 11 times y power 11 by 2, again 0 to 1. Now for y we will substitute the upper limit. So that will become 1 only. So this will become simply 2 by 3 minus 4 by 7 plus 2 by 11 64. So 64 by 231. So this is the answer. So here we have to evaluate integral 0 to 1 sine inverse of 2x by 1 plus x square dx. So we have to see what value we have to substitute for x so that this gets simplified. That means we have to write this in terms sine inverse of sine, like that it should come. Then what value we can substitute for x? You can put x is tan theta. 2 tan theta by 1 plus tan square theta is equal to sine 2 theta. So let x is equal to tan theta. This gives dx is equal to secant square theta d theta. Here x varies from 0 to 1. When x is 0, put x is 0 here, tan theta is 0. This gives tan theta is equal to 0. Again this gives theta is equal to 0, because tan 0 is equal to 0. When x is equal to 1, here x is 1 means tan theta is 1. Tan 45 degree is 1. So theta is equal to pi by 4. Therefore 1 becomes is equal to integral x is 0, theta is also 0, theta is 0, theta is pi by 4. Then sine inverse of 2 tan theta by 1 plus tan square theta, dx is what? Dx is secant square theta d theta. Now we have written everything in terms of theta now. So this is nothing but now 0 to pi by 4 sine inverse of, this is sine 2 theta secant square theta d theta. Sine inverse of sine, so that becomes integral 0 to pi by 4 sine inverse of sine 2 theta is 2 theta only into secant square theta d theta. Now we have to evaluate this integral. We will take 2 outside, integral 0 to pi by 4 theta secant square theta d theta. How to evaluate this integral now? You can see here integral theta, integral x is secant square x dx form. That means we have to integrate this by integration by parts. We will integrate secant square theta. If we integrate secant square theta, what will come? Tan theta into second function theta. So for this we will substitute the value 0 to pi by 4, then minus integral of integrated function tan theta into differentiation of other function theta. If we differentiate with respect to theta 1 into d theta comes. Now 2 times, if you put theta is pi by 4, tan 45 degrees 1, theta is pi by 4. So 1 into pi by 4 minus tan 0 is equal to 0. Then minus, this minus comes here. If we integrate tan theta, what will come? Log of secant theta. again 0 to pi by 4. So this is nothing but 2 times pi by 4 minus this bracket. For theta, substitute 45 degrees, secant 45 degrees. So log of secant pi by 4 minus log of secant 0. So this is nothing but 2 times pi by 4 minus cos 45 is 1 by root 2. So secant 45 is root 2. So this will become log root 2 minus cos 0 is 1, secant 0 is 1 by 1, that is equal to 1. So log 1. Two times pi by 4 minus log root 2, that we can write as log of 2 power half, and log 1 value is equal to 0. So when you multiply this, pi by 2 minus 2 times, this we can write as a half log 2. This is, so this 2 gets cancelled, the answer will be pi by 2 minus log 2. So this is the answer. Here x plus 2 is coming under square root, so we can take let x plus 2 is equal to t square. This gives dx is equal to 2t dt when x is 0, t square is 2, and t will become root 2. We are taking plus root 2. When x is 2, t is equal to 2 plus 2, 4. T square is 4, so t will be 2. Here also I am taking positive value, here also I am taking positive value. And therefore 1 becomes equal to integral x varies from 0 to 2 and t varies from root to 2. X is what now? X is t square minus 2, and square root of x plus 2 is t square. So square root of t square, and dx is 2t dt. So this gets simplified to root 2. This will become only t into t square. This 2 will take outside. Then t into t square t power 4 minus 2t square. 4I is equal to 2 times, we will integrate t power 4 with respect to t, it will be t power 5 by 5 minus 2 times t cube by 3 root 2 2 times. For t you put upper limit, so 2 power 5 by 5 minus 2 times 2 by 3 times 2 power 3 minus, then for t substitute the lower limit root 2 power 5 by 5 minus 2 by 3 times root 2 power 3. The answer. In this integral, if we take cos x is y minus sin x dx becomes part of dy. So we'll take let cos x is equal to y. This gives what? Minus sin x dx becomes dy. When x is 0, what happens to the value of y? X is 0, cos 0 is 1, so y is equal to 1. When x is equal to pi by 2, y is equal to cos pi by 2 is equal to 0. Y is equal to 0. Therefore, 1 becomes equal to integral x is 0 means y is 1, x is pi by 2 means y is 0, sin x dx minus dy by 1 plus y square. So this minus we will take outside. So minus integral 1 to 0 dy by 1 plus y square. So minus integral 1 to 0, we can write this as integral 0 to 1 dy by 1 plus y square. 0 to 1 dy by 1 plus y square is nothing but minus 1 to 0 dy 1 plus y square. This is by using properties of integrals. That integral dy by y square plus 1 is equal to 1 by 1 into tan inverse y by 1. So that is nothing but tan inverse y. 0 to 1 tan inverse 1 minus tan inverse 0, tan inverse 1 is pi by 4 minus 0 is equal to pi by 4. Tan 0 is 0, so tan inverse 0 also is equal to 0. So integral dx by x square plus 2x plus y is there. We can bring this to the standard form of integral dx by x square plus a square form. So we can write this as integral minus 1 to 1 dx by x square plus 2x plus 1 plus 4. 5 we are writing as 1 plus 4. So this is nothing but x plus 1 whole square plus 2 square. So this is in the form of integral dx by x square plus a square. So what the answer? 1 by a, so 1 by 2 tan inverse of x by a minus 1 to 1. x by a, in place of x plus 1 is there, so I written x plus 2, in place of a 2 is there, I written 2. Now half times tan inverse of, first I will substitute x is 1, upper limit, 1 plus 1, 2, 2 by 2 is 1, tan inverse 1 minus tan inverse of, put x is minus 1, minus 1 plus 1 0, 0 by 2 is 0, tan inverse 0. So this half times tan 45 is 1, tan 45 degree is 1, so this will be 45 degrees minus 0, so this is pi by 8. See this integral 1 to 2 of 1 by x minus 1 by 2x square into e power 2x dx is there. But we know the formula, integral e power x into x plus f dash x dx, this is equal to e power x into f of x plus constant. We can apply this formula only, e power x is there, otherwise it is not possible. We have to write this e power y form, so let 2x is equal to y. Then 2 dx is equal to dy. When x is 1, y is equal to 2, and when x is equal to 2, y becomes, x is 2, y becomes 4. This therefore 1 becomes integral x varies from 1 to 2, y varies from 2 to 4, 1 by x, 2x is y, what is x? X is y by 2, 1 by y by 2 minus 1 by x is y by 2. So 2 times y by 2 whole square e power y, what is dx? Dy by 2. Now we will take the 2 outside, integral 2 to 4. This we can write as 2 by y minus, this is y square by 4. So 2y square by 4. So y square by 2. So it will become 2 by y square e power y dy. I is equal to, this 2 will take outside. So 2 by 2 equal to 1. So 2 by 4 times e power y into 1 by y minus 1 by y square dy. Integral 2 to 4 e power y f of y plus f dash y dy, when f of y is equal to 1 by y. So what if we differentiate f of y, this y power minus 1, so f dash y is minus 1 by y square. So this value is equal to e power y into f of y 2 to 4. So e power y, f of y is nothing but 1 by y. So y 2 to 4. Now we'll substitute the upper limit for y, e power 4 by 4 minus e square by 2. Now we can take e square by 2 commonly outside. So e square by 2 minus 1. So this is the answer. Thank you for watching. So tomorrow we are going to see the properties of definite integrals. Thank you for watching.